In the situation seen on the diagram, we have an interconnected body system where two masses are joined or interconnected by means of a string around a smooth rotating pulley. One of the masses is on an incline and the other is freely hanging. What do you think will happen? Will the 6 kilogram mass rise and the 4 kilogram mass fall? Or will the 6 kilogram mass slide down and making the 4 kilogram mass rise? Well, if the situation was slightly different, like the one on the right, you would say that so long as the surface was frictionless, the 4 kilogram mass will fall and the 6 kilogram mass will rise. In order to determine what will happen in our original system, we would need to analyze the forces acting on the body. So the external forces acting are 40 Newton force acting on the 4 kilogram mass, and the 60 Newton force acting on the 6 kilogram mass represent the gravitational forces acting on each block. Additionally, for the 6 kilogram mass, because it's in contact with the surface, it feels a normal reaction force perpendicularly away from the surface, and this is represented by this diagram here. We do not know the size of this force. We will assume for now that the surface is frictionless, so there are no frictional forces acting between the 6 kilogram block and the sliding surface. In order to progress further, we need to break down and analyze the 60 Newton weight force into a component parallel to the slope and the component perpendicular to the slope. To do this, we will have to draw perpendicular and vertical lines parallel and perpendicular to the slope, both at the head and the tail of the vector. This will give us the resulting parallelogram. The magnitude of the sides of the parallelogram will give us the components that we need. The component downslope, otherwise the component parallel to the slope, is this, and represented by this side of the parallelogram, and the component perpendicular to the slope is this, represented by this side of the parallelogram. Now, since the block will only slide up or down, we haven't decided which yet, the normal reaction force must be equal to the component of the weight acting perpendicular to the slope. So there is no net force along this direction. Therefore, the external forces that are acting on our system of interconnected particles are the 40 newtons, which is acting to roll it downwards and move this upslope, and the component of the weight that's acting downslope. As we had analyzed previously, the component of the weight acting downslope can be found by the gravitational force, or the weight, times sine 30. In this case, the weight is 60 newtons, and so the gravitational force is 60 times the sine of 30, which is a half. That means the component downslope is 30 newtons. So on the system of interconnected bodies, we have 30 newtons pulling it down this way, but 40 newtons pulling it down this way. In this case, the mass, 4 kilogram mass, will fall, and the 6 kilogram mass will rise up the slope. You may have thought initially the opposite. So what happens if we increase the angle 30 degrees? Well, the sine of the angle 30 degrees will also increase, making this component larger. When this component becomes above the 40 newtons, then the system will begin to slide down slope. At a specific angle, F gravitational sine 30 will equal exactly 40 newtons. That means that the two systems will be held in equilibrium. They will be balanced. 40 newtons is trying to roll it downwards, but 40 newtons on this side is acting on the whole system to try and keep it stationary. Let us return to the current situation. We have a 40 Newton force acting downwards, and the F gravitational sine 30, which is 30 newtons, acting to push it this way. Therefore, the net force, which is acting on the bodies, is 40 minus 30. And that net force is acting on both the system of interconnected bodies, the 6 and the 4 kilograms, so a combined mass of 10 kilograms. Applying Newton's second law, the acceleration is F net divided by mass. F net is 40 minus F gravitational sine 30. And that's divided by the total mass that it's accelerating, which is 10 kilograms. And doing the mathematics gives us an acceleration of 1 meter per second squared. So these kind of questions combine all our knowledge on interconnected systems and inclined slopes.